Hello, this is Reading Week 5 for Physics 2211. The focus of this week's material was on contact interactions. We began with tension, which is commonly seen in wires suspending a system. Something to note about tension, while we always know which direction it has, the magnitude of the force changes based on the situation. We do know that the magnitude of the tension force will increase with the magnitude of the force that's pulling down or stretching the wire, and that the magnitude of the tension force is the same throughout the wire in most cases. This leads us to the next topic covered, normal force and friction. In high school physics, we learned about these two forces as separate entities, rather than components of one force, what we call the surface contact force. This interpretation makes a lot more sense to me, especially as they explain that it's all based on the chemical bonds. Friction is not necessarily opposite the direction of motion, it's just away from the side with compressed bonds and towards the side with stretched bonds, because it's a restoring force. This part in particular was interesting to me because I'm also learning about this in a materials science class that I'm taking as part of my major. We recently finished up a discussion on how equilibrium distance between atoms in a bond and how there are attractive forces and repulsive forces at play that will pull the atom back together or separate it, and it makes up the forces that we're discussing now. It's pretty interesting because between the two classes, I'm able to see the different applications of this one property. The normal force was very familiar, though I had learned about it as its own thing. The overall concept was still fairly secure in my mind. It was previously explained to me as an application of Newton's third law, as in if you push on the table is going to push back with equal amounts of force so that you don't fall through the table. Another concept discussed was how to work backwards in a problem. If we're given the motion, or can observe it, how do we find the net force? The video also laid out a helpful step-by-step guide, which is very useful considering that's what I struggle the most with in physics. I can understand the concepts, but the way to approach the problems and what exactly I need to do at what times, that's always what trips me up. So although this is the most difficult concept, the video did help mitigate that to some extent. The last big topic was static and dynamic equilibrium. Static equilibrium is exactly what it sounds like. A system is stationary and balanced. Dynamic equilibrium is a little harder to wrap your head around though. It mainly deals with objects that are in constant velocity motion and usually ends up with us having to use sliding rather than stationary friction to solve it, but it is remarkably the same problem-solving process, despite looking very, very different as a problem. One outside resource I found was the physics hypertext book. It not only has practice problems for statics, that's what I was looking at simply because that's the topic we were on currently, but also detailed explanations as to what information you need to be utilizing in each aspect of the problem, along with diagrams. I will definitely be using these to prepare for quizzes, tests, as well as investigating the site further to see if they have additional practice for topics that will be tested on for our first exam. A second source I found to better understand is the Physics Libre text. This was written more as like a short explanatory article compared to the hypertext book that was focused on practice, practice, practice. However, it also references the free body diagrams and also provides a roadmap of sorts I can follow when solving these types of problems. And that in particular is much more helpful to me than just purely conceptual review, but it also has a healthy dose of review as well. And that wraps up the reading for week 5. Thank you for listening.